Hi friends, welcome to my YouTube channel. So today I am here with a new question from the physics optional previous year question paper. The question is from the topic quantum mechanics and it is related to uncertainty principle, the generalized uncertainty principle. The question is a particle is described by the wave function psi of x equal to pi by 4 whole raised to minus 1 by 4 e raised to minus ax square by 2. Calculate delta x delta p for the particle and verify the relation delta x into delta p equal to h cross by 2. So let us see how we can do this question. So before doing this question, I would say you have to remember some standard integrals. So the standard integrals I will write here one by one and you have to remember them. Not only for this question, for many questions this will be useful. So the first one is integral minus infinity to plus infinity e raised to minus ax square dx. This is equal to root of pi by a. Second one is integral minus infinity to plus infinity x into e raised to minus ax square dx. This is equal to 0. Third one is integral minus infinity to plus infinity x square e raised to minus ax square dx. This is equal to square root of pi divided by 2 times a raised to 3 by 2. So if you know these three integrals, this question will be very simple. So how we can calculate delta x and delta p? I think everyone know this formula. Delta x is equal to square root of expectation value of x square minus expectation value of x the whole square. Similarly, px equal to square root of expectation value of px square minus expectation value of px the whole square. So we are asked to prove delta x into delta p equal to h cross by 2. Okay, so let us see how we can prove this. First of all, let us look at the wave function. The wave function here is given as this. This is the wave function. So first of all, let us see whether the wave function is normalized or not, and if it is not, let's find out the normalization condition. So I will write normal psi prime equal to n into psi, where n is the normalization constant and psi is given by pi by 4 raised to minus 1 by 4 e raised to minus ax square by 2. So for normalization, integral minus infinity to plus infinity n square psi square n square psi star psi equal dx equal to 1. That is n square into integral minus infinity to plus infinity. We put the values here. Pi by 4 raised to minus 1 by 4 e raised to minus ax square by 2 into pi by 4 all raised to minus 1 by 4 e raised to minus ax square by 2 dx. This is equal to 1. So we can take the constant outside. This become pi by 4 raised to minus 1 by 2 integral minus infinity to plus infinity. This and this become e raised to minus ax square dx. And we know the value of this. Already I have written here. E raised to minus ax square dx is root pi by root a. So this is equal to 1 and this is n square into pi by 4 raised to minus 1 by 2 root pi by root a. This is equal to 1. So this pi and this pi will get cancelled. So what do you get as n square is equal to root a divided by root 4 or is equal to root a by 2. This is the normalization constant. So once you know the normalization constant, now the question becomes very simple. So we know that expectation value of x is equal to integral minus infinity to plus infinity e raised to minus ax square by 2 n into this n prime is the total constant by 2 x into raised to minus ax square by 2 dx. So now we have n, instead of n we have here we have n square root a by 2 into the other constant pi by 4 all raised to minus 1 by 2 integral minus infinity to plus infinity x into e raised to minus ax square dx. Now I have already written this x into e raised to minus ax square dx become 0. This integral is 0. So one thing we have to find out is, only thing is this integral expectation value of x square. Expectation value of x square is given by what? Integral minus infinity to plus infinity n psi star into a x square into n psi dx. So instead of n we can write this become n square into psi star x square psi dx. This become n square into, sorry, I just made a mistake here. Okay, let's leave it here. I will erase it here. Okay, so instead of n square, what we have already calculated root a by 2 into integral of pi by 4 raised to minus 1 by 2 into x square a raised to minus ax square dx. So this is equal to root a by 2 into this term pi by 4 raised to minus 1 by 2 can be written as root 4 by root pi into the remaining integral is minus infinity to plus infinity x square e raised to minus ax square dx. This value is already calculated. This is root pi by 2 a raised to 3 by 2. So many things will get cancelled out here. And what is remaining is 1 by 2a. This is what x square is. So since we have x square is there, delta of x is equal to square root of expectation value of x square minus expectation value of x the whole square. This is equal to, just take the square root 1 by root of 2a. Okay, so now we have delta x. Similarly, we can calculate delta p. So delta p calculation is, it's also very simple, but let us first of all calculate delta expectation value of px. This is equal to integral minus infinity to plus infinity n into psi star. What is the operator for px? This is minus ih cross d by dx into n into psi dx. So the constant can be taken outside, n square integral minus infinity to plus infinity psi star into minus ih cross into, we know that d by dx of e raised to minus ax square by 2 is equal to minus a by 2 into 2x into e raised to minus ax square by 2. So this is what we substitute here. This become minus a by 2, 2x e raised to minus ax square by 2 dx. So this constants we can take outside. I will put this constant here, but just say the term. Here only the x comes here, therefore this term becomes 0 as per our standard integral. So average of px is also 0. And what is remaining is average of px, expectation value px square. So expectation value of px square is equal to integral n square psi star minus h square d square by dx square psi dx. So now this thing you have to carefully calculate. I will calculate it here. D square psi by dx square equal to d square by dx square of raised to minus ax square by 2. So this we can calculate and you will get the expression as a minus ax square into a square x square into e raised to minus a square by 2. So substitute these values here. I will substitute here n square I already know is root a by 2. Then there is a pi by 4 raised to minus 1 by 2. Then there is an a I can take outside. Then that become two integrals minus infinity to plus infinity a raised to minus ax square dx minus similarly root a by 2 pi by 4 raised to minus 1 by 2 into a square into integral x square raised to minus ax square dx. Calculating these two, evaluating these two integrals, you will get this. You can just calculate it. You will get it as 1 by 2a x square. Therefore, x delta p is equal to 1 by root 2 into root a into h. H cut. Now, question is very simple. Delta x equal into delta p is equal to 1 by root 2 into root a into 1 by root 2 into root a into h cut. These terms are cancelled out. What remains will be h cut divided by 2. Now this question you have to do a lot of calculations and the steps are very important, otherwise the question is very simple. So how we have calculated this, remember this is a little bit confusing. We are given normally they give if there is a constant given already in the wave function, that wave function should be normalized, but here the wave function is not normalized, and only after normalization we can go to calculating the steps. So the steps is the standard integrals you have to remember, and also you have to remember that delta x equal to square root of expectation value of x square minus expectation value of x whole square. Similarly, we can calculate delta x and delta px, and substituting the value we will get here what we get x cut by 2. So I think the question is understood by everyone. I would like to thank Mr. Abhishek Sinha for correcting me because I have done a mistake there while doing the problem. So he was the one who corrected it. Okay, so let us meet with a new question in the next class. Till then, if you have any questions or queries, you can write in the comment box. So till then, goodbye everyone.